Monte Carlo simulations rely on generating random samples to estimate probabilities and solve complex problems. But how do we efficiently generate samples from different probability distributions? There are several important sampling techniques, including inverse transform sampling, rejection sampling, importance sampling. Each method has its advantages and is used in different scenarios. 1. Inverse transform sampling. This technique is useful when we can express a probability distribution mathematically. It works by transforming uniform random numbers into samples from the desired distribution. Here's how it works. First, generate a uniform random number between 0 and 1. Then apply the inverse of the cumulative distribution function CDF to get a sample from the target distribution. For example, if we want to generate exponentially distributed numbers, we apply the inverse function to uniform random numbers. This method works well when the inverse function is easy to compute. 2. Rejection sampling. Rejection sampling is useful when direct sampling is difficult. It works by generating candidate samples and accepting or rejecting them based on a probability rule. The process involves choosing a simple distribution, like a uniform or normal distribution, to generate candidate samples, computing a probability ratio to determine whether to accept or reject each sample. For example, if we want a sample from a complex distribution, we first generate samples from an easier one, then accept them based on their likelihood in the target distribution. While powerful, rejection sampling can be inefficient if too many samples get rejected. 3. Importance sampling. Importance sampling is a smart way to improve efficiency when estimating expected values. Instead of sampling directly from the target distribution, we sample from a simpler known distribution and adjust the results using weights. Why is this useful? In Monte Carlo simulations, some rare events are crucial but hard to sample. Importance sampling allows us to focus more samples on important regions, reducing variance and improving accuracy. For example, in financial risk modeling, importance sampling helps estimate the probability of rare market crashes by prioritizing extreme events in the simulation. Which sampling technique to use? Use inverse transform sampling when you have an explicit formula for the cumulative distribution function. Use rejection sampling when direct sampling is hard, but you can approximate the distribution. Use importance sampling when estimating probabilities of rare events to improve efficiency. Conclusion: sampling techniques are key to Monte Carlo methods. Understanding when to use each technique ensures we can generate random samples efficiently and accurately, leading to better simulation results.